Welcome once again to a new episode of the Future of Business podcast. I'm April with Fast Future Publishing, and in today's episode, I have David Saintloth reading his chapter, The Rise of the Cosmeceutical Sector. Find out more about David and the book, The Future of Business, over at fastfuturepublishing.com. Before we get into today's chapter, I do have a special announcement. Starting December 15th, Fast Future Publishing will begin selling the award-winning book, It's Your Future, Make It a Good One, by Dr. Vern Wheelwright. It's Your Future takes the strategic foresight and scenario planning tools that successful corporations like Shell and Google have used for years and scales them down for the individual to use. The book takes you through a simple step-by-step process that'll help you discover your desired future and actually help you build a feasible plan to reach that desired future. The book was awarded Most Important Futures Work by the Association of Professional Futurists and is a special offer starting December 15th, the day we start selling the book, for 7 days only. If you use discount code IYF20, you'll receive 20% off of your purchase of It's Your Future. Make it a good one. That code again is IYF20 for 20% off of the book. And keep an eye out, or rather keep your ears open, because between now and December 15th, I'll be posting a few podcast specials about this book. I've got an interview with the author, Dr. Wheelwright, as well as a few sneak peek readings of It's Your Future. Make it a good one. More details can be found at fastfuturepublishing.com. Now, on to the chapter. Today's contributor, David Saintloth, is a U.S. entrepreneur, designer, and a writer, and in his chapter, he highlights how gene editing technology could enable the emergence of a new cosmeceutical health and beauty sector. Here's David Saintloth reading his chapter, The Rise of the Cosmeceutical Sector, from The Future of Business.
Hi, I'm David Saintloth. I'm an entrepreneur, engineer, illustrator, designer, and transhumanist. I've garnered 17 years of experience in the IT and software space, primarily focusing in publishing, collaboration, and workflow. I invented the action-oriented workflow paradigm and implemented it in the Agile Entity Distributed Application Framework. I'm the founder of A Priority LLC and WorkNets, a startup currently in stealth. My areas of principal research include the future of work and autonomous workflows, the extension of autonomous workflows to artificially intelligent systems, what I call dynamic cognition, the utilization of the aforementioned technologies to create a self-healing infrastructure that enables humanity to pinch off the production loop entirely, ushering in an age of autonomously provided abundance. And finally, and more correlated with the focus of my chapter in the future of business, the development of technologies in genetic engineering and biotechnology toward the flexible modification and or creation of living systems, and ultimately ushering in for humanity what is called supermortality, or indefinite life extension. My chapter covers a newly emergent area that I call cosmeceuticals, the mating of genetic engineering technology enabled by gene editing advances to allow fluid modification of human phenotype. In short, enabling us to change how we look as readily as we change our clothes or shoes. In 2013, the invention of new technology is poised on radically changing the existing market segment of cosmetic hair and skin product industries. What are the nature of these shifts to come? In this article, we'll analyze the shift to come from each of the sub-industries based on the appearance of this new technology. Before the new power. The facts of life. To make an alteration in the evolvement of an organic life system is fatal. A coding sequence cannot be revised once it's been established. Dr. Tyrell from Blade Runner. And thus began a fictional conversation between a billionaire scientist and one of his creations, the Nexus 6 version of the replicant biosynthetic beings in the form of the deranged Roy Batty. An exchange where Batty implored at one point, "I need more life, Father," expressing his frustration at the inability for his maker to provide a solution for the rather pressing problem of an engineered 4-year lifespan for all replicants. The crux of the difficulty, as Tyrell explained it, was that changing the genetic sequence of a living organism could not be done without inducing some form of cancer formation, oncogenesis. During the time of the writing of the short story from which the movie was based, Philip K. Dick's Do Robots Dream of Electric Sheep, genetic science was in its infancy. We barely had tools beyond X-ray crystallography in order to probe the molecular construction of living cells. It was akin to feeling our way blind to understanding how DNA discovered and characterized by Franklin, Watson, and Crick in the 50s was coded into the dynamic creature that teemed the entire planet. And so it is that when this film was made in the early 80s, the very idea of replicants was high science fiction, perfect fodder to tickle the imagination of those that in the future would dream to make possible what Tyrell believed in his fictional world was impossible. The truth was all around us. The irony of Tyrell's discussion is that we animals, living things that undergo changes of state that take us from 2 cells in mammals, the germline cells of our parents, to clusters of billions of different cells, such a transformation must necessarily require the revision of our genetic code. In real time, different parts of our genetic inheritance are activated, executed across multiple pathways, and then shut down. We grow and evolve as physical beings because of the ability for our systems to, in real time, modify the expression of the contained genetic code. Conceptually, this is no different from what Tyrell described as being impossible, with the difference being that what Batty wanted was to have his existing genes modified so that he could have extended life. With the sequencing of the human genome in 2000, it became more clear that a significant number of our pathways were coded for by complex interactions of existing genes, rather than what had been previously believed, what was termed the central dogma of one gene, one protein. The realization that humans were fully represented by only about 25,000 true genes left no doubt that complex interactions between the genes and subsystems were at play to allow expression of the over 100,000 or so types of tissues that are produced in our bodies. These low-level systems include restriction enzymes, RNA subcomplexes performing complex interference, and other, at the time unknown systems, up until the dawn of the second decade of this millennium. The invention of CRISPR-Cas9. In 2012, the first signs emerged that it could be possible to utilize various complexes of biomolecules to perform targeted modifications to the genes of a given organism. This first technique was termed TALENs, for transcription activator like effector nuclease. They were great at binding to genetic sequences of a given type, but were not as specific as was hoped. They have been useful in allowing researchers to create specific knockout organisms for study, but their lack of specificity makes them not an ideal solution for performing the in vivo genetic editing that would be required for us to overcome Roy Batty's limitation, at least in theory. That method, though, was also being developed around the same time as TALENs, and it was called CRISPR, clustered regularly interspaced short palindromic repeats. CRISPR seemed to magically provide all the benefits of TALENs, with significantly higher specificity and very low possibility of oncogenic triggering. The power of the method has now crossed into the zeitgeist, as the creators of the technology, led by Dr. Jennifer Doudna, have come forward to declare that they are against utilizing the technique for performing germline or somatic cell editing until the ethical ramifications of the technology are fully explored. In writings on the future of genetic engineering technologies that I have been producing for years, I predicted the invention of gene editing technology. About 7 years ago, I stated it would one day lead to a future of custom genetic modifications in real time that would produce a multi-billion-dollar industry, and that is what has been called the age of cosmeceuticals. Cosmeceuticals. Though difficulties still remain to be ironed out regarding the specificity issues with CRISPR, they are not technically limited and are very likely to be overcome. Assuming that they are overcome, the ethical barriers will be all that remain. And for many types of conceivable modifications, these concerns are definitely worth thinking about, attempting to prevent, though Pandora's box is likely already open. CRISPR modifications are not excessively difficult to perform, and already the global field of biohackers are salivating at the possibilities that the technology makes possible. The field of cosmetics itself in the US is a $60 billion industry that is growing. The global industry is nearly 4 times that, at $250 billion. The question remains, what does this pending cosmeceutical industry mean for business? The main takeaways for business will come when the low-hanging fruit modifications are targeted by research teams. What I consider low-hanging fruit are changes that have lucrative market segments and are unlikely to have strong ethical or legal proscription against funding. The following list details these areas. Targeted hair growth. Imagine being able to modulate how and where hair grows on your body. The combination of CRISPR-like technology and increased understanding of how hair follicles are activated across the landscape of our largest organ will lead to the ability to genetically induce such growth. This will provide a massive market for those who have issues with hair growth to particular density or in locations of their body, and will emerge as a low-hanging method to monetize the new technology. In 2016, the hair care products industry is estimated to be $83 billion US. Targeted hair elimination. As a corollary application of gene editing technology for hair is the removal of hair. As we understand what causes hair to grow in the first place and can turn on or off expression of hair growth, we can precisely remove hair from unwanted locations genetically. The billion-dollar shaving industry will be significantly impacted by this technology, which when applied to the germline could lead to lifelong modification that does not require continuous purchase. So Gillette and other companies are in big danger of having their market taken over once these technologies are on the market. The US men's shaving market, for example, was a $3.6 billion market in 2012. Hair texture change in vivo. The hair products industry owes a great deal of its existence to the varied types of texture of hair expressed by different lineages of the human family. Billions of dollars a year are spent by people of all genders seeking to make their hair curly or straight. With the continued investigation on the genetic triggers for modifying the root of hair and by geometry inducing changes to curl, and then vectoring genetic edits to those parts of the genome that control those triggers, we will affect an ability to genetically modify the type of hair texture that emerges. Rather than using harsh chemicals, heating irons, or pressure to modify hair texture, genetic treatments will allow modification in germline or somatic line, thus permanently or for a period of time. It should be obvious how lucrative such an industry would be once companies figure out how to induce desired modifications. In addition to the existing market, the potential for opening underserved demographics in the ethnic markets of Africa, Central and South America, and the Caribbean could create a brand new revenue stream for genetically modified treatments to modify hair texture where currently a very tenuous market of many custom and not efficiently produced at-scale products are in place. This market has been estimated at being up to potentially $500 billion in size on a global basis. Hair color change in vivo. The global hair color products industry is already at $7 billion per year and is expected to grow. This market is ripe for a new type of disruption that is possible should the full details of the mechanisms of hair color are identified and then using CRISPR-like technology employed to create temporary or germline modification to change hair color naturally without any chemicals or damage to the hair itself. It is known that the significant contribution to hair color lies in the concentration and type of melanin expressed to the roots. Once this sub-mechanism is identified and how it is modified using various types of enzymes and the genetic sequence modifications that enable them, changing hair color genetically will be a trivial affair. It may be possible going forward to add in entirely new expression profiles, say to generate hair of novel colors, that currently humans can't express, by studying other mammals that do produce those colors or simply adding in the modulating genes. The power of gene editing is mostly been focused on allowing changes to existing genes, but the same technology is able to add in entirely new genes and thus make completely new functionality possible. Eye color change in vivo. The global color contact lens industry is expected to be $13.47 billion by 2019. This offers a huge opportunity to do for eyes what could be done for hair using CRISPR-like technology. The process will again follow analyzing the specific genes involved in melanin concentration in the tissues of the iris. As well, it may be possible to also modulate tissue geometry, which is also known to affect the apparent color of the eye by use of diffraction effects to incoming wavelengths of light. However, the means investigating and cracking this problem and enabling gene editing to allow people to modify their eye color as a fashion will allow access to this fast-growing industry. Skin color change in vivo. Finally, and in this case a brand new market to be explored, the genetic modification of skin tone will affect a huge impact on various ways in which human lineages have interacted in the last few centuries. The social and cultural strife created by adherence to beliefs of difference based on skin color will be finally eliminated when humans can be dark-skinned one month and light-skinned the next. The social ramifications of technology will be legion. Aside from the market opportunity is indeed a great one. In India alone, a country dealing still with the effects of colonial and cultural stigmas revolving around skin tone, the skin lightening industry is $432 million. The US market for tanning products is estimated at $773 million. Summary. With the invention of in vivo gene editing, human society will be impacted in unexpected ways. All apparent value to the concept of race becomes obsolete, one fabricated during the slave trade and purposed to prosecute the slow genocide of peoples simply because of the color of their skin or the texture of their hair. The emergence of new markets of genetic modification to the phenotype expression of the underlying genotype may do more to foster the cohesiveness of the human family and allow us to finally shake off the pernicious fabricated evils of a past where our external differences were used as tools of oppression and hatred. How impactful will this shift in society as a result of these markets be? What role will businesses have in directly shaping the influence of their technology so as to both be profitable and a benefit to mankind? The future marketers of the industries that will emerge to service the demand that exists globally to allow people to appear as they wish on their own schedule, and if they wish to propagate their conception of self through to their children, will have their hands full selling humanity the dream of flexibility in phenotype that had simply only existed in fiction up to now. Can they create ethical campaigns to allow servicing these markets most efficiently? The opportunities for growth are in the hundreds of billions of dollars across all the segments mentioned above, and the swift and the bold will be those to take advantage of the potential of the new technology to service the demand. If you'd like to discuss any of the concepts described in the podcast, send me an email at davidsaintloth@gmail.com. That's davidsaintloth@gmail.com. If you're interested in reading the motherlode of my writings in the 4 pillars of research indicated previously, my blog, Sentinel Space, is the place to go. That's Sentinel, which is spelled SENT, the number 2, NULL.BLOGSPOT.com. Also, don't forget to pick up a copy of the book at www.fastfuturepublishing.com. Thank you for listening and joining me as we explore the future of genetic modification to phenotype via the new industry of cosmeceuticals.
Thanks for listening to the podcast today, and a special thanks goes out to David for recording his chapter. If you do like the podcast, do us a favor, go into iTunes, go into Stitcher Radio, or however you listen to this podcast, and give us a rating or a review. And if you have any specific feedback about the podcast, you can always reach me at april@fastfuturepublishing.com. And don't forget, beginning December 15th for 7 days only, you can pick up a copy of It's Your Future, Make It a Good One, for 20% off with the coupon code IYF20 at our store at fastfuturepublishing.com. Until next time, I'm your host, April Corey, and I'll talk to y'all later.